What's up, math scholars? It's a sunny day where I am. I hope it's sunny where you are. I am going to teach you section 10.1, day 1, graphing, and we're going to have to be in radian mode today. So who's excited about radian mode? Woo, 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 woo! It's just me in an empty classroom. All right, so just a refresher on how the mode works. You want to grab your calculator, hit mode button right here at the top in the middle. I'm in degree because I'm still in chapter 9 in my world, but we're going to do radian mode for chapter 10. Exit out, and we'll be using this calculator later on today. Okay? First things first, do you have your unit circle anywhere nearby? Just found mine. All right, we're going to label this circle with coordinates and radians. So right here, we start off at 0 radians, and this is the coordinate 1, 0. Up at 90 degrees, we call that pi over 2 radians, and it's the coordinate 0, 1. Over 180, that's pi radians, and that's the coordinate negative 1, 0. And then down at 270, that's 3 pi over 2 radians, which is the coordinate 0, negative 1. All right, we're going to be using all those coordinates to do both sine graphs and cosine graphs today. And you should have probably already done the spaghetti activity, so you kind of already have an idea of what the graphs look like. If you haven't done the spaghetti activity yet because you're working ahead, it's fun. We'll get to that soon. All right, so officially we're on 10.1 day 1, sine and cosine graphs. We already talked about the smileys. We already talked about radian mode, so let's get into it. What we're going to talk about here is the 4 key points around the unit circle, and one actually repeats because at 0 radians we're at 2 pi radians. So first of all, for key points, we are doing sine. So when I tell you what is the sine at 0 radians, what would you tell me? What is the y value at 0 radians? It'd be 0. What is the sine value at pi over 2 radians? So go to pi over 2 on your unit circle. Look for the sine value. It's at 1. If you would go to pi on the unit circle, which is 180 degrees, what is the sine value there? 0. Let's head down to 3 pi over 2. What is the sine value down there? Negative 1. And then when we complete, we're back to where we started, but I'm going to call that 2 pi, and the sine value where we started was 0. Now, here's how we're going to graph that on our unit circle. Or, I'm sorry, on our coordinate plane. The x-axis is going to be our radians. So at 0, 0, I'll obviously live at the origin, but my next hash mark will be at pi over 2, and I'll live up at 1. Let's just call this 1 right here. So that's the coordinate pi over 2, comma 1. Next, I would label this pi. At pi, we're at 0. At 3 pi over 2, we are down at negative 1, so around here. And then at 2 pi, we're back to 0, and this is the sine wave. I just graphed what's called 1 period of the sine function. So period takes 2 pi to happen. That's how long a period is. Now the amplitude is how tall it gets, or the distance from the origin up to here. That's the amplitude. So our amplitude is just 1. The domain is where this graph is allowed to travel from left to right, and it can travel left and right wherever it wants. But for range, where the graph can travel up and down, it's just from negative 1 to 1, including negative 1 and 1, because they actually do touch at negative 1 and 1. So that was pretty fun. This just kind of talks about amplitude a little bit more in depth and shows it to you on a diagram. The amplitude is normally from the x-axis up to the peak of the curve. It will change in some of the graphs we look at. And then this talks about period a little bit more. Period is how long it takes to complete one cycle. Since our cycle started here and then it ended here, our period was 2 pi, but that will be changing as well in different problems that we do. In the graph we looked at today, it was 2 pi. All right, this actually gives you a formula for amplitude and period. For amplitude, it's the absolute value of A, and for period, it's 2 pi over B. That's if you're in the form y equals a sine bx and y equals a cosine bx. Okay, it's time for us to look at a cosine graph, so keep in mind when I'm asking you questions, you're looking at the cosine values, or the x values. Let's start at 0 radians on our unit circle. At 0 radians on the unit circle, what's the cosine value? 1. At pi over 2 radians on the unit circle, what's the cosine value? 0. At pi radians on the unit circle, what's the cosine value? -1. At 3 pi over 2 radians on the unit circle, what's the cosine value? 0. And at the end, back to the beginning, I guess, 2 pi, we're back to 1. All right, so let's graph it. We're going to start at 0, 1 this time, so that would be here. By the time we get to pi over 2, we are at 0. By the time we are at pi, we're at -1, which is down here. 3 pi over 2, we are back to 0. And then 2 pi, we're at 1. So cosine is also a wave graph, but it starts at 1 and ends up back at 1. And it continues in either direction. So the period is still 2 pi, and the amplitude is still 1. The domain and range are still the same as well. Oh, that should have been a positive one. Now I'm curious if I messed that up on the sine graph. I'm going to pause and check that. All right, I checked that. Now it's perfect on the sine graph. All right, so let's just kind of compare and contrast our sine graphs to our cosine graphs. Just so, again, a reminder, a sine graph starts at 0 and ends at 0 for its first period. A cosine graph starts at 1 and ends at 1 for its first period. So they're going to have the same domain and range. Both domain and range are -infinity to infinity. That just means same. Both the ranges are -1 to 1. Nothing's different. Now the x-intercepts are going to change. The x-intercepts for the sine graph, I guess we can go back and take a peeky peek at them. The x-intercepts for the sine graph are 0, pi, and 2 pi. 0, pi, and 2 pi. I'm going to put a ... because it will happen every single pi units if I would continue to the right or the left. Let's look at the x-intercepts of the cosine graph. It's pi over 2 and 3 pi over 2. And if I wanted to find more, I would just keep adding pi. Because it happens every pi as well. The y-intercept of a sine graph is 0 right here. The y-intercept of a cosine graph is 1 right here. So those are different as well. But the periods are going to be the same. It's going to be 2 pi for each. I don't think there's anything else hiding at the bottom. Oh, amplitude. If it's just a normal graph and there's been no changes, it's an amplitude of 1 for both sine and cosine. All right, now it's going to get a little bit trickier. What we're going to do is transform a basic sine or cosine graph with a and a b value. So just again, when I talk about an a and a b value, the a lives out front. That's going to affect the amplitude. And the b is going to be sitting with the x. That's going to affect the period. But here's how we're going to actually apply the change to each of our key points one at a time with this formula. This is a very important formula to write down. 1 over b times x. So basically all your x values in your key points will get multiplied by 1 over b, and that will affect the period, or the horizontal stretch and shrink. The a value will get multiplied by the y values, and that will affect the vertical stretch and shrink. So that's going to affect the amplitude. So make sure you have that in your notebook. Very important. So let's look at a problem with an a and a b value other than 1. This particular problem has an a value of 5 and a b value of 2. The 5 will affect my amplitude. The 2 will affect my period. The amplitude will be 5. I'll go ahead and write that down now. If I want to figure out what my period will be, I'll do 2 pi over b, or 2 pi over 2. So the period will just be a pi. So it'll be shrinked in from what we have seen earlier today. What I have in this first column are my original key points of a sine graph without any change to them. So my key, if you remember right, from my key points in my sine graph, at 0 radians, sine is 0. At pi over 2 radians, sine is 1. At pi radians, sine is 0. At 3 pi over 2 radians, sine is -1. And at 2 pi radians, sine is 0. Now, here is what we are going to do. We have to make some changes and apply some changes. What's going to happen here with our change? It's called S because it's called a scale change. Is I'm going to do 1 over b times x, and I'm going to do 5 times y. So everything in my x column that I'm underlining in blue is going to get multiplied by 1/2. So 0 times 1/2 is 0. Pi over 2 times 1/2 is pi over 4. Pi times 1/2 is pi over 2. 3 pi over 2 times 1/2 is 3 pi over 4. And 2 pi times 1/2 is pi. So that has now affected the period. Now, 5 times y, everything in the y column, everything I'm underlining in green will get multiplied by 5. So 0, 5, 0, -5, and 0. That's going to affect our amplitude. Let's graph it. We have this new nice handy graph. I actually grabbed this from the CCP pre-calculus teachers. We were trying to set you guys up for success in that class. This is the graph you'll be using in that class, especially if you have Mrs. MacDonald. 0, 0 would go here. Now this is a pi. It's hard to read, but this is actually a pi right here. So if I'm going to estimate where pi over 4 would be, it's 1/4 of a pi. So about here at 5. Half of a pi, I'm back to 0. 3 pi over 4, I'm down at -5, and at pi, I'm back at 0. So you can see we actually did a whole period in the space of only 1 pi. The domain is still -infinity to infinity, but as you guessed, our range is different. That amplitude is now 5, so the range is -5 to 5. All right, we're only going to do one more problem today, and then I'm going to show you how you can graph these in your calculator to check your work. This particular problem has an a value of 2, that's going to affect the amplitude, and a b value of pi, that's going to affect the period. So amplitude is 2. Period, again, the formula is 2 pi over b. So 2 pi over pi, the period would end up just being 2. And that's going to get interesting when I go to graph this, because my graph has the x-axis in pi's. But, you know, I could always just relabel my x-axis depending on what my key points look like. So this time my key points are coming from a cosine, or x values as we travel around my unit circle. At 0 radians, my cosine value is 1. At pi over 2 radians, my cosine value is 0. At pi radians, my cosine value is -1. At 3 pi over 2 radians, my cosine value is 0. And at 2 pi radians, my cosine value is 1. All right, let's talk about our scale change. It's going to be 1 over b times x. So 1 over pi times x. And a times y will be 2 times y. Let me do my y's first. I think they're going to be the easier ones. All the numbers I'm underlining in green, I'll just multiply by 2. So 2, 0, -2, 0, and 2. All right, this one's going to be a little trickier. Everything I'm underlining in blue, I'm going to do 1 over pi times that number. So this will stay at 0. If I do pi over 2 times 1 over pi, let me put my work here. Pi over 2 times 1 over pi, guess what happens? The pi's go away, so it's just at a half. If I did pi times 1 over pi, I'd just be at 1. If I did 3 pi over 2 times 1 over pi, I'd just be at 3 over 2. And then finally, if I did 2 pi times 1 over pi, I'd be at 2. So I'm really thinking renumbering this axis would be most beneficial to me. I'll just have this be a 1, this be a 2, this be a 3, and this be a 4. You're allowed to renumber your axes. It's your graph. So 0, 2, 1/2 0, 1, I'm at -2. 3 over 2 is 1.5. I'm back at 0. And at 2, I'm back at 2. So there's my cute little cosine graph. My domain is -infinity to infinity, and my range is -2 to 2. That was fun. These are a lot of work, so that's why we're only doing a few graphs today. I think we did 4 total graphs today. But now I'm going to show you a really cool window. This is actually suggested by Mrs. MacDonald herself. A good window to allow you to graph these in your calculator. Again, make sure you're in radian mode. We did that at the beginning of the video. Let's hit window. I think I'll move this over. Give me 1 second. Window. So she has just decided these are the best windows to be able to see these graphs. The x minimum, she's making -2 pi. Again, the pi button is second caret key. The x maximum, she's making 4 pi. And I just noticed they converted that pi to decimals, which is super cool. I didn't see that coming. The x scale, she's actually making that pi as well. Y minimum -5, y maximum 5, and scale is 1. So let's just try graphing one. How about we go back and graph that one we just did on the previous slide. Go grab that formula again. It was 2 cosine pi x. 2 cosine pi x. And it should show you the graph, which is super cool. It looks exactly like the one we made. It's just scrunched a little more. But yeah. It's a cool way you can make these graphs on your calculator. Hey, thanks for watching the video today. Hope you learned a lot. See you next time.